I have the absolute pleasure to introduce you to Dr. Hermenzo Gomez. Hermenzo is the product manager for 3D X-ray microscopy. And during this session, he's going to give us some insight into how important 3D X-ray microscopy is in the field of medical device development. Hermenzo, great to have you here.
Thank you, David.
Could you give us some insight into why this is such an important field?
Yes, for sure. As it happened, manufacturers of medical devices face some interesting challenges when trying to do quality inspection of these mechanisms. For one, they are composed of internal mechanisms that move inside and that cannot be seen with the eyes. They are drug delivery devices, so the dosage need to be controlled, so you don't give extra medicine to the patient. They also need to comply with government requirements, and sometimes they have very tight tolerances. They need to make it easy for customers to use, so they can operate this in an easy way. And as you can see, medical devices, though you see a lot of plastic components, they also have metal components like springs or some light metals and gears that move, so those move internally. And as I already mentioned, you cannot inspect them visually, so you need some more advanced type of technologies like X-ray to inspect them.
Okay, that sounds extremely complex and there's a huge amount of variation in the requirements. Can you give us an understanding as to how we go about doing that?
Yeah, for sure. That's where the interesting part of these conversations starts.
Very good.
So I'm going to show how. So here, David, I have just put a device in a fixture and I'm going to place inside of the machine so I can show you how it actually works.
Okay, very good. Hermenzo, just to be clear, the X-ray source is off whilst the doors are open.
Oh yeah, of course. You're not going to be
that's
radiated here, so don't be concerned. Yes, this is just a demonstration, so everyone can see it, just how the machine will work, but without the X-rays on. So what you see here is basically three components: the flat panel, which I'm going to use to collect a full view of the device, and an X-ray source and a stage that is going to rotate the part. What you see now is the flat panel is going away because the second scan I want to do is to bring a set of lenses, and there are several possibilities to increase the resolution in a small field of view. Okay. I'm actually going to use the 4X, and that 4X is going to scan in a small region of interest. Okay. It's going to give us much better resolution than the traditional flat panel to be able to see some of the internal components of the part, the plastics, and maybe some particles that I'm going to show you later. So X-rays not only help you to do a quick assembly inspection of the part in 3D. Once you have the 3D data, you can also check for internal defects, delamination, void or air pockets in the material, foreign particle or inclusions that shouldn't be there, material analysis of powders or medicines that you have there. And on top of that, you could do a dimensional analysis, dimensional measurements, nominal to actual comparison to a CAD model, and wall thickness analysis. So there is a wealth of analysis that you can do with the 3D data once you get it.
Very good. I never realized there was so much you could get from one scan.
Yes, for sure. Let me show you in the computer now, in computer analysis. All right, David. So here is where the magic happened. I am here with Nathan Ney, application engineer for X-ray products, and he is going to show us the data in 3D reconstruction using ZEISS Inspect. Go ahead, Ney.
So one of the nice parts is once we have that data reconstructed, we can bring it into the software and we can actually go through the slices in every axis. We're able to do visual inspection, assembly analysis, failure analysis, but we're also able to do metrology on this as well. But one of the perks with 3D X-ray microscopy is that we can actually take a closer look. So as an example, if we wanted to look on the actuator here, we can actually zoom right in. And in this case, we can actually see some of the particulate that is actually around that actuator itself.
So that's the scan that we took with the second lens, with the 4X lens, when zooming in a small region of interest.
This is with the 4X lens, correct?
Good.
And same thing here, we can zoom in and we can actually see if there's any blockages or anything of that sort.
And what is that you see in there?
So what you're seeing here is this is the the cone of the actuator so we can actually see the particulate as it's building up around that actuator, so we can see all the medicine there that's actually being kind of blocking that actuator.
Wow, that's really interesting that you can actually see the particulates. That's very hard to scan with X-ray, but it's great that this system is able to see it.
Amenzo, you've covered many different aspects of what X-ray microscopy is capable of doing. What I'd really like to do is get down to the nitty-gritty and the bits and pieces that are really interesting to the audience. What are the benefits for the customer?
Yeah, for sure. Let me try to summarize that in a few bullet points. To start, 3D X-ray inspection is the best solution for checking internal features of a device without having to disassemble or destroy the sample. And some of the main benefits of 3D X-ray inspection, which are multiple, are it accelerates the product development, the speed of development time, accuracy, and increased profitability. It reduced the time to market, cost, and project risk. And on top of that, it simplified failure analysis and quality control with a wealth of valuable information for all kinds of analysis post-scanning process.
That's very interesting. Just to summarize, we've covered the hardware, what it looks like, the capabilities and how it works. We've covered the software, the different types of evaluation we can get just from one scan, and we encapsulated it in this excellent presentation. Can I please thank you and your team for spending time with us today?